This is section 12.2, finding limits algebraically. The top has all of our properties, this top box. You can split limits up with addition, subtraction. There's scalars in here. You could split it up by multiplying or division. Make sure that the limit of the denominator doesn't equal 0. Okay, so we could actually do it in pieces and then find what it is entirely. You could even do it separately with exponents and square roots. So here we have this graph of f and g. F is in red, g is in blue. So we're actually going to take this limit, this a. Let me write it skinnier. So I'm going to do the limit as x is approaching -2 of 2f of x. And then I'm going to take the limit as x is approaching -2 of 3g of x. So you can actually take out the scalar as well. So 2 limit as x is approaching -2 of f of x minus 3 limit x approaching -2 of g of x. All right, so if we're looking at f of x and we're approaching -2. As we approach -2, the limit looks like it's hitting 1. So this is 2 times 1 minus 3 times. If we're approaching g at -2, looks like it's going right here, down at -1. So 2 plus 3, this is equal to 5. The second one, we are multiplying, so we're doing the limit as x is approaching 1 of f of x minus 2 times the limit as x is approaching 1 of g of x. Well, honestly, before I go any further, at 1, the blue graph, g, is approaching 2 different values, which means this doesn't exist. So if we're trying to multiply something that doesn't exist with something that does exist, this still doesn't exist. Okay? So this one doesn't exist. Let me write that a little bit neater. C, final limit is x is approaching 1 all to the third. So as f of x is approaching 1, right there, that's up at 2. So C, looking at 2 cubed, which is 8. And then the last one, f of g over f of x over g of x. We're approaching 2. Well, that one is f as it approaches 2. It's right there, 1.5. I need some room here. And as g approaches 2, which is 0, well, that doesn't exist. You can't divide by 0. On the bottom, some special limits. The limit of a regular value is just its value. The limit of just a plain x is the x that it's going towards. This one, you're just plugging in a, and same thing, this one, plug in a. All right, sometimes it's easy just to simplify. Well, I mean, to plug in. So if we're evaluating this, this isn't really fancy, it's just a quadratic, so I'm actually going to plug in -2 and evaluate it for what it would be at. The answer is 31. Here, if I plug in 0, I get 0 minus 2 on top, 0 squared plus 0 minus 6 on the bottom. -2 over -6 is 3. No, it's not. It is 1/3, not 3. So that's direct substitution, what I just did. But sometimes it doesn't work out so well. Not in these, not till we get later. So we're going to plug in 2, so 2 squared plus 6 times 2 over 2 to the 4th plus 3, and we get 16/19. Here if we plug in 3, we get 12. This bottom one, if you plug in 4 to the denominator, you'll get 0. If you plug 4 into the numerator, you still get 0, right? Which means you need to somehow reduce this stuff. So we have x minus 4 on top. Oops. Double bubble the bottom. X minus 4's go away. So I'm really taking the limit as x goes to 4 over 1 over x plus 4. Now I can direct substitute, getting 1/8. Limits are on the final exam, just so you know. Same thing, if you plug in 0, you're going to get 0 on the bottom and 0 on the top. So we will my 16 goes away. These 3 terms all have an h in common. Cancel that out. So I'm really taking the limit as h goes to 0 of 8 plus h. Well, if h is going towards 0, that piece goes towards 0, leaving me with an 8. That's called the difference quotient there, which we will see, we have seen, and we'll see a lot more of. All right, if you plug in 1 here, 0 over 0, which means we can't do. So we have to do something with it. I'm going to multiply it by square root t plus 1. Yes, we are rationalizing the numerator. It's okay. Things will work out. So we get t minus 1 on top. And the bottom, just leave it in bubbles because you're evaluating it anyways. And this is what you're taking. Oh, the t minus 1's go away. So this is equals to 1 over t plus 1. And that's what we're doing the limit as. T going to 1. So 1 over square root of 1 is 1. 1 plus 1. This is 1/2. Right hand and left hand, we've talked about that. The limit as x approaches 0 for the absolute value of x. Well, that graph is this right here. So as we're going down here, they both equal 0. This graph doesn't exist, and I'm pretty sure it's a horizontal graph. I'll put it in though. So I have to do the absolute value of 2x divided by parentheses 2x, not 22, 2. Graph. Oh, wait, hold on. Yeah, I was pretty sure it was a split graph. So this is going this way, goes this way. So approaching 0 from 2 different sides doesn't exist. And this one, it says find the limit of the piecewise defined function. Why not? Put in your calculator. So the first one, square root of x minus 7. Second one, 28 minus 4x. And we are looking at x really at 7. Make that 0. Make this 20. Okay. 1, 2, 3, 4, 5, 6, 7. So here at 7, this is the first part of the graph that we drew. And then for x less than 7, it's this piece right here. So this is actually not on there. Okay, it's just this top piece. So as we're both approaching from the left and from the right, it's down there at 0. So our answer, 0, is x approaching 7. That is the section on algebraic 1.